We are given a system of equation a square minus b equal to 111 and b square minus a equal to 111. We want to solve those two system of equation. We have two unknown and two system of equations, so we should be able to solve it. Let us write this one as equation 1 and this one as equation 2. Now we subtract equation 2 from 1 because we can see the right hand side the numbers are same. If we subtract it, we'll get 0. Of course, when we subtract one equation from another, we should change the sign. So plus will change to minus, minus will change to plus, plus will change to minus. So we can write, after subtracting, a square minus b square plus a minus b equal to 0. Now you see that we can factorize a square minus b square. So we can write this as a minus b into a plus b plus a minus b equal to 0. Further, you can see that we can take a minus b common. A minus b and a minus b. If we take it common, then we obtain a minus b into a plus b plus 1 equal to 0. Now we have product of two number equal to 0. It cannot happen that both are non-zero. So we must have either a minus b equal to 0 or a plus b plus 1 equal to 0. If both are non-zero, product of two non-zero number is again non-zero, so that equal to 0 will not hold. Now if a minus b equal to 0, then it follows that a equal to b, or if a plus b plus 1 equal to 0, then it follows that a equal to minus 1 minus b. Let's look at the easier case, a equal to b. When I take a equal to b, let us consider equation 1 that says a square minus b equal to 111. So by equation 1, a square minus b equal to 111. But you see, b can be written simply as a because those two numbers are same. So that implies a square minus a equal to 111. Let's take this quantity 111 to the left hand side. So we obtain a square minus a minus 111 equal to 0. This is a quadratic equation. A general quadratic equation is of the type ax square plus bx plus c equal to 0. And roots are given by x equal to minus b plus minus root over b square minus 4ac divided by 2a. So let's apply this result in this case. This is a quadratic equation and the coefficient of a square is 1, coefficient of a is minus 1 and the constant term is minus 111, minus 111. So a equal to minus b, so minus of minus 1 plus minus root over b square minus 1 square minus 4 into coefficient of square term, that's 1, and into constant term, that's minus 111, divided by 2a. Now the coefficient of square term is just 1, so 2 into 1. So a equal to minus of minus 1 is 1 plus minus root over 1 plus 444 divided by 2. So that gives us a equal to 1 plus minus root over 445 by 2. Now we see that in this case we are taking a equal to b. That's the case we have started with. Therefore, a comma b is given by 1 plus root over 445 by 2 comma 1 plus root over 445 by 2 or 1 minus root over 445 by 2 comma 1 minus root over 445 by 2. So those are the two possibilities for A and B. Let us look at the second case. As we have seen earlier, we got product of two numbers equal to 0. Then we must have either one of them equal to 0 or other equal to 0. If the first were 0, then we got A equal to B. If the second were 0, we got A equal to minus 1 minus B. So let's look at the second case, A equal to minus 1 minus B. Again by equation 1, A square minus B equal to 111. That's obtained by equation 1. Let us eliminate B. From here we can write B equal to minus 1 minus A. So that gives us A square minus of minus 1 minus A equal to 111. And so we can write this as A square plus A minus 110 equal to 0. Okay, now once again we get a quadratic equation. We can apply this formula, x equal to minus b plus minus root over b square minus 4ac by 2a. But this turns out to be simple one because 110 can simply be factorized into 2 into 55, and that again can be written as 2 into 5 into 11, and we can apply splitting the by middle term method. So a square plus 11a minus 10a minus 110 equal to 0. 11 into minus 10 is minus 110, and 11 minus 10 is just 1. So we are applying splitting by middle term method. So we are splitting 1 is 11 minus 10. Now we take a common. We'll be left out with a plus 11. If I take minus 10 common, we'll be left out with a plus 11 equal to 0 as it is. So once again we take a plus 11 common, and we are left out with a minus 10 equal to 0 as it is. So you see that once again we have product of two numbers equal to 0. So one of them has to be 0. So either it must happen that a equal to minus 11, or it may happen that a equal to 10. But b equal to minus 1 minus a, that gives us b equal to minus 1 minus 11, or minus 1 minus a minus of 11 is plus 11, and minus 1 minus 10. So that gives us in the first case that imply b equal to 10 comma minus 11. Oh, I see. A comma b equal to, we just need to interchange it, minus 11 comma 10 minus 11 comma 10, or we'll just interchange it 10 comma minus 11. Yes, minus 11 comma 10 or 10 comma minus 11. Yes, we are done.